So I've written an extension for Lean4 that renders morphisms inside a category as string diagrams, which you can then use to rewrite these morphisms and manipulate the expressions to prove equalities between them. The extension begins by checking the proof state, and if you're trying to prove an equality between two morphisms, then it will pass this equality and it will pass the expression on the left hand side of the equality and the expression on the right hand side of the equality to produce two string diagrams describing them, which you can then use to click on the natural transformations and the morphisms inside the diagram to change and rewrite and manipulate the diagram itself to prove the equality between these two morphisms. It does this by generating tactics inside Lean, which you will see on the left hand side inside the editor. So inside this file I have a few example statements about monads to demonstrate how the extension works. Here I have an instance of the associativity law for the mu natural transformation, and to prove my statement that this left hand side is equal to the right hand side, I can click on the mu natural transformation here, and I can click on the mu natural transformation here. And now I have proven my statement by generating this tactic over here. Here I have an instance of the eta natural transformation and the mu natural transformation. And over here I have the identity. So I can click here, and I can click here, and I have generated a tactic which then solves this goal. Here I have I have the eta natural transformation again, but before we wanted to show that it's the unit, here I want to show that it's the left unit and the right unit, and in fact these two expressions are equal. I can do this by first clicking here and clicking here, which generates a tactic, and if I actually remove this simplification over here, I can apply the same tactic on the right hand side, and then I can close this goal. Down here I have a combination of a few different monad laws to prove what was in fact a sub-goal from trying to prove that filtering after joining is the same as joining after filtering when you have a list of lists. So I have the monad mu natural transformation, an arbitrary morphism guard, and another instance of the monad mu natural transformation. So I can do this first by using the naturality of mu to swap the order between them, and visually you can see I can just pull up the morphism since there's no issue with doing that, it's like a string. And then it generates the tactic to do so, and I can rewrite the diagram as such, which generates the tactic above. On the right, I can either use the associativity law on the left hand side or the right hand side. I'm going to do it on the right hand side, they are the same. And then I get my goal is now proved, and that's the extension. It's for proving equality between two morphisms inside a monoidal category.